Guilty Abumfanabo, so welcome to Science Intellect Hub. My name is Mr. Mojaki Sanise. They call me Mr. Mfanabo. So, halala, right now. So, Mfanabo, I welcome you to the study of functions. That is what we are going to talk often about. Well, the study of functions is very, very costly when it comes to paper 1. If you recall, as far as paper 1 for grade 10 is concerned, this topic costs 30 marks plus minus. Remember that paper 1 is out of 100 for grade 10 level. So it means 30% will come from functions. Then when you go to grade 11, it is 45 plus minus. That's a lot of marks. In grade 11, then it decreases a little bit to be 35 plus minus. That is because in grade 12 rather, we want to introduce a few things. So we want to open some space there. That is why the marks decreases a little bit. So, halala, right now. So welcome indeed to the study of functions. Well, functions, honestly, when we talk about them, they are just interested in the relationship between variables. And these variables could be input variables or output variables. So functions will be interested in the relationship between variables. Usually, we use letter X usually for inputs, and we use letter Y for outputs. So from there, then we can be able to see that usually inputs are what we call independent variables, and outputs are what we call dependent variables. We'll discuss that in the next slide. But I want to take you a little bit back, more than half a decade ago, of course, when you had no feelings whatsoever. Do you remember we had something called the spiral diagram? Well, the spiral diagram, for instance, is if I was having y equals 2x as my rule, and my inputs were as follows: 1, 2, 3. So you can see that in actual fact my corresponding outputs will be what? 4, 6, 8. Where rather it will be what? It will be 2, 4, and then 6. How about that? So from this, then I want you to check something here. We had inputs and we had outputs and we had our rule. So we were looking at the relationship between variables here. So that is what functions is all going to be about. Good job. Now, something of importance then when it comes to function is what we call a relation. I want us to know that when we talk about a relation, we are talking about a set of ordered pairs. For example, in my previous slide, my set of ordered pairs will be 1:2, or rather we'll say the set of 1:2, 2:4, 3:6. That is my set. That is my relation, my set of ordered pairs. So now from each of those, we had what we call the X and we had what we call the Y, and they follow one another in that manner, where of course the X will definitely be our input and the Y will then be our what? It will be our output. Then in terms of the language that we just learned currently, our X then will be the independent variable, whereas our Y, our output, will be the dependent variable. And this relation then is very important then in that it can allow us to even go graphically, whereby we can draw the Cartesian plane, whereby the Y will be represented by the vertical line or the vertical axis, and the X will be represented by the horizontal line or horizontal axis. So halala, right now. So that is why when we go graphically and we draw our graphs, usually we will have this as our x-axis and we will have that as our y-axis. And our x-axis, then that is where we are going to have our input. That is where we are going to have our inputs in actual fact. That is where we are going to have our freely chosen independent variables. So halala, right now. Whereas when we look at the vertical axis, the y-axis, usually that is where we will have what? We will have our output variables. That is where we will have our dependent variables. Then when we are in a Cartesian plane, I want us to be aware then that the set of input variables zange exam mfana boss. So njalo nje. When we look at the set of the input variables, the set of dependent variables, those gives us what we call the domain. Halala, right now, good job. The domain. Whereas then when we look at our output variables, which of course gives us our dependent variables, that then gives us, when we look at the set of all the output values, looking at the set of all the dependent variables, that then leads us to what we call the range. So halala, right now we refer to that then as being the range. The range then by definition being the set of all possible output values. A good job. Now let us get a bit technical. We are moving at 120 kilometers per hour. Rema super blind in front of us. So good job. Now let us get a bit technical, of course, and try to find out then as to what is a function then? So we ask. Well, technically speaking, they say a function is a relationship between two variables. For simplicity purposes, we will say it's a relationship just between two variables. But realistically speaking, it can get more complicated than that. So let us get the basics right so that when life gets complicated, we are up to stand. Good job. So a function then is a relationship between two variables such that to each value of the independent variable. So I like the fact that this technical definition of what a function is uses the concepts that we've already introduced ourselves to, such as what is an independent variable. It is simply the input variables. I hope we recall something of that nature. So independent variables, of course, will be our input values. Good job. So a function is a relationship then between two variables such that to each value of the independent variable there corresponds exactly one. Listen to that. There corresponds exactly one value of the dependent variable. We will explore later what do we mean by saying there corresponds exactly one value of the dependent variable. Remember, by the dependent variable, we know now that we are talking about our output values, which will give us our range if we were to be concerned with that. Good job. So we will in actual fact explore what do we mean that there corresponds exactly one value of the dependent variable, because that is very important to the definition of what a function is. So we are getting technical here. Well, we will use what we call function notation. That is what we will use. We will use what we call function notation, whereby we say y is equals f of x. So instead maybe of writing y is equals 2x, we will say no man, we are matured for such. We would rather write something like f of x is equals 2x. That implies the same shit in front of us. So job. Halala, right now. So what is happening in function notation is that the f there is the name of the function. That is what the f is. It is the name of the function. Remember, we can call our function h of x. We can call our function maybe g of x. We can call our function k of x. We may call our function any alphabet whatsoever. For so long, we have the ability to name our function, but most commonly, we use f, because why not? Then y is the dependent variable. Do you remember we said y is equals f of x? So if y is the dependent variable, f of x then is the dependent variable as well. So with the dependent variables, with the output values, when we combine all of them, of course, we may talk about what we call a range. Remember, by definition, a range is simply the set of what? The set of all possible output values. Whereas when we talk about the x is the independent variable, and it will lead us to what we call a domain. Those are very, very important concepts that we need to know rough and about. My screen is getting a little bit messy, but I like it that way. I'm a mathematician. I like some mess, because why not? For us, we are moving at 120 kilometers per hour. Super blind. So the independent variable, of course, is our input values. And if we were to combine all of our independent variables, if we were to combine all of our x values, if we were to combine all our input variables or input values, of course that will give us the set of the domain, or rather the set of input variables, which is the domain. And they say f of x is the value of the function at x. Check, that is very important. F of x is the value of the function at x. Do you remember when x was 1, using y is equals to x? When x was 1, y, f of x, or f of 1 was 2 then in our example. So there is a difference between f and f of x. F is the name of the function, whereas f of x is the value of the function at x. So, right now that we have an idea as to what is a function, let us talk about ways in which we can represent a function. Of course, we can represent a function verbally through the use of words. For example, in our case of y is equals 2x, we may use words and say, there exists a function whereby for every input, the output doubles. Remember in our spider diagram example, when the input was 1, the output doubled and it was 2. When the input was 2, the output doubled and it was 4. Ganjalo. So that was us, of course, representing a function verbally. We can also do so, of course, numerically, maybe through the use of a table, or maybe a set of ordered pairs, so we say. Right now. Another way, of course, in which we can represent a function is algebraically. Algebraically, for instance, we may say y is equals 2x plus 1. How about that? Or of course, we can use our function notation that we've introduced ourselves to, just to make it a little bit fun. How about that? Do I wanna job? I'm fun about so. Right now. So algebraically, using a function notation, we may say f of x is equals 2x plus 1. Now another way, of course, in which we can represent a function could be algebraically, or rather graphically, whereby we may make use of the Cartesian plane. Remember, the horizontal axis is the x-axis, the vertical axis is the y-axis, and of course maybe our graph could be a linear function as follows. And we are going to focus quite a lot between algebraic and graphical ways of representing our functions. We are moving at 120 kilometers per hour, mfana boss. Super blind. Now that we have an idea of what a function is, we are asked a very important question here. They say, are the following relations even functions? Are they functions? So they ask. Let us get back a little bit technical into reminding ourselves as to what is a function.
A function is a relation. Remember, a relation is a set of ordered pairs where there will be inputs and there will be outputs for sure. So a function is a relation in which each possible input value leads to exactly one output value. That is very important. Remember the previous definition that we had said the same thing but in a different way. This one then makes it a little bit clearer to say that a function is a relation in which each input value or in which each possible input value leads to exactly one output value. We say that the output is a function of the input. The input values makes up the domain, as we said, and the output values makes up the range. I hope we remember that. By saying that each possible input value leads to exactly one output, think of it in this way. You are pressing a calculator, 2 plus 2, it gives you 4. You try again and you press the same calculator, 2 plus 2, it must give you 4 again and again and again, or a bonatab. That is because that input is reliable. Our calculators are reliable. So inputs need to be reliable in order for us to consider it as a function. So let us consider these relations that we are given here. There is P, it's an input. It gives us what? It gives us one output and only one output, which is M. Q gives us N. R gives us N. So each possible input value was mapped to exactly one output value. Meaning each possible input value led us to exactly one output value. But you may say N is shared there. Yes, it's shared, but each possible input value gave us exactly one output value. It just happened here that N was common for both Q and R. So this relation is a function. Whereas when we look at letter B, they say, is this relation a function? Of course, when you look at the inputs there, each possible input value leads us to exactly one output value. So that relation is a function. Very interesting is letter C. They say, is this relation a function? Well, let's look at P. P gives us X, okay? That's fine. At least that input value led us to exactly one output value. Now there is Q becoming a little bit of a problem there. Q gives us Y, Q gives us Z. So Q does not give us exactly one output value. It gives us two output values here. So this is not a function. This relation is not a function. So we can see that indeed some relations can be functions, some relations definitely are not functions, such as this one. Check. So this is not a function in Fanabo. So this for using the calculator example, you press 2 plus 2, it gives you 4. Now you press 2 plus 2, it now gives you 7. Icon. So that one cannot be able to happen. Why? Because our calculators are reliable. Because input values needs to be reliable. Each possible input value must lead us to exactly one output value. So halala right now. Here we want to know as to whether the following relations functions. Just a reminder, we said a function is a relationship, of course, between two variables, such that each value of the independent variable, corresponds to exactly one output value. That is very important. Corresponds to exactly one output value. So when you look at this relation here, remember we have different ways of representing functions. This is a way of representing functions. But the question that we are having here is, are the following relations even functions? Are they functions? So we ask. When you look at the first one, the input -2 gave us one output value, which was 5. The input value -1 gave us 8. 0 gave us 6. 1 gave us 6. 2 gave us 7. So we can see that each input value gave us exactly one value of the dependent variable, or one value of the range, so we say. So that means this one is indeed a function. But when you look at number 2, the domain here, or the input variable -2, it gave us 3. -1 gave us 3. -1 again gave us 4. Icon. So we can see here that the input value does not give us exactly one output value. It gave us 2 different output values. So this one, without even going further, is not a function. So we can say not a function. Definitely.
Of course, we are moving at 120 kilometers per hour. Remasepa blind mfana boss. Now, if you found value in this video, please ensure to like, comment, and subscribe. Gimahala. Welcome to Science Intellect Hub. My name is Mr. Majagisanese. They call me Mr. M. Fanboss. So, till we meet again, peace.